So today's lesson is uncertainty of a tool. So when you're looking at making a measurement, that measurement, what you write down isn't exactly what it is, right? There's a little bit of fudgy room in there. So we're going to talk about that. I will collect data using analog and digital tools, ensuring accuracy and precision in measurements. Okay, so when you're using any tool, it is important to understand the precision of the tool that you're using. Precision in a tool is the degree to which an instrument will repeat the same values. Okay? To show the precision of a tool used to make the measurement, we add the uncertainty or error after the measurement. Okay? So, for example, if you measured something that was 12.1 meters, but you were using like a huge meter stick, right, that only had meter markings on it, you would be able to say that it's 12.1 plus or minus 1 meter. Okay. This is referred to as the absolute uncertainty. Okay. Keeping the precision in mind, it is important to choose the correct tool for the measurement. If you want to measure micrometers, you are not going to use a meter stick, right? You need something that can measure down that far. Okay. All right. For an analog tool, analog tools are tools that don't have a digital readout, right? The precision is determined by taking half of the smallest possible measurement. Okay, so for example, a meter stick is an analog tool. Okay, uh, rulers are analog tools, that kind of thing. Okay, so if you're measuring in centimeters using the meter stick, the smallest measurement that you can make, right, would be a 0.1 of a centimeter. That would be, each one of the tiny black lines. Okay, you're going to take half of that possible smallest measurement. Okay, so the smallest measurement would be 0.1 centimeters. Take half of that, so your uncertainty would be plus or minus 0.05 centimeters. Okay, so if you're saying that you're measuring something and it is 9.6 centimeters, it would be 9.6 centimeters, or 9.6 plus or minus 0.05 centimeters. It's important to know where the units go when you're writing it. For digital tools, the error in the measurement is always plus or minus 1 of the last digit. Okay, so if I'm looking at this digital scale, it says 97.9. That 0.9, that is your last digit. So it would be plus or minus 0.1. Okay. So in this case, it would be 97.9 plus or minus 0.1 kilograms. Okay. Again, this is called your absolute uncertainty. While precision is very important, we also want an accurate measurement. Okay, so precision is how close are they together? How close are your trials together? Okay, accuracy is how close are you to the accepted value? Okay, so if you buy a piece of wood from the hardware store and it says that it is we'll use inches, 5 inches long, right? It's possible that they cut it wrong, and so it's only 4.8 plus or minus 0.1. Okay. But, but that's pretty close to it, right? So how close are you to what is the actual measurement should be? Okay. Avoid the following measurement techniques because they cause error. We've talked about the actual ruler itself can have an error, but the way you use that tool could introduce even more error or more uncertainty. Okay. And that is not measurable. So if you don't put the zero placement in the right spot, so here I have my tool that I'm measuring, and I'm measuring it from the zero mark, not from the edge of the ruler. Okay. So make sure that your object is aligned at the zero mark, which is not always at the end of the ruler. Incorrect positioning. You want to make sure that your tool is straight. Angles can skew the reading, right? So, we already kind of learned about measurement at angles, right? So that angle, you could end up with a longer measurement than what you should have. So make sure that you are as straight as possible. Okay. And then if you're using a digital tool, make sure that your tool is set to 0. So if you're using a sensor and you're supposed to be measuring the height of something, you want to make sure that you set that sensor at 0 so that you're getting an accurate measurement. Okay. Parallax error is when you're not looking straight on to get the measurement, you're looking sideways. So like if you've ever been in a group and you've got 3 people standing there and they're all trying to make the same measurement, you're not going to get the same results because you're not straight on. You're not looking at it straight on. Okay. And then there are environmental factors. Be aware of the environment where the measurements are to be done. So for example, if you're using a gram scale, air can cause the scale to skew its readings. It can either blow it up, which would make the reading come out smaller, or it can push it down, which would make the reading heavier. So, just pay attention to the surroundings, as well as if your object is ice or if it's a solid of some sort, right? They're going to give you different readings because ice can melt. Okay, so to sum it up, the precision in a tool is the degree to which an instrument will repeat the same value. Analog and digital tools have uncertainty. Accuracy is how close a measurement is to the known or accepted value. And then using the tool correctly can help you to reduce error in your measurements.